Hi and welcome. I'm trying to learn particle physics. Today, the weak nuclear force. And after we've done it, we're gonna do Neckstretching. And if you participate in the Neckstretching, then it's valid on risk. Let's read what we had in the first part. Fundamental force, the weak nuclear force, governing theory. Electroweak theory, unified theory with quantum electrodynamics, a theory of electromagnetism, and high energies. So it's part of a unified theory of quantum electrodynamics, a theory of electromagnetism, and high energy, whatever. Mediator are the W and Z bosons, so over them it is transported, and typical range are 10 to 18 meters. Of the four known fundamental forces, the weak nuclear force has the least obvious purpose. Its effects were first discovered at the turn of the 20th century in the place where it is most obviously at work, in radioactive beta decay. In the most common form of this decay, beta minus decay, a neutron decays into a proton, also splitting out a negatively charged electron to conserve electric charge. Okay, beta minus decay is a neutron decaying into a proton and splitting out an electron to preserve a neutral charge. Beta plus decay does the reverse and turns protons into neutrons and splitting out an electron. This amounts to an ability unique to the weak force to change the flavor of the quarks that make up protons and neutrons. For example, switching a down quark to an up quark or vice versa in beta decay. Wait, does that mean that there is this beta minus decay happening? And is that the weak force? Which makes... I don't know how the weak force is. Let's see that. It sounds quirky, but it is far more irrelevant. Only the action of the weak force changing protons into neutrons within a star like the Sun allows nuclear fusion to get off the ground within its core orbit. Okay. The weak force is so weak because... Oh, that's why it's called like that. The weak force is so weak because, unlike the massless photon that carries the electromagnetic force, the three boson particles that carry it, the WZ and Z boson, the W plus, W minus, and Z zero, are very massive. Oh, that's interesting. Okay, the W and Z boson are carrying it, and there exists a W plus and W minus boson. And the Z boson seems to be there's a zero written after that, so the Z is neutral. Whatever. They are massive. They are able to transport something. The photons are massless. They are carrying the electromagnetic force. According to the rule of quantum field theory, the seldom bubble up from the vacuum and have only a very short range. The existence of these particles was confirmed by physicists at the research centers near Genua, Switzerland in 1983. Okay, but W plus and W minus and Z0 exist, which was discovered in 1983 at CERN in Switzerland. In fact, as was discovered in the 60s, the weak force and electromagnetism were part of the same unified electroweak force in the early universe, until it underwent a process known as spontaneous symmetry, breaking as it cooled, rather like a phase transition when a gas condenses to a liquid. See. To what part of the sense it belongs to stay. We're going to read it in a moment all again. This process led to the W and Z particles gaining the mass. So they gained the mass because the electroweak underwent a process known as spontaneous symmetry. And it broke when it cooled down. Such like, or rather like, a phase transition in which a gas condenses to liquid. So in this process led to W and Z boson particles gaining the mass, while the photons stayed massless due to their interaction with another field and its associated particle, the Higgs boson. Okay, the photon is massless. That's why it can travel so fast. Due to the interactions with other fields and its association with Higgs boson. Let's do this part again. It sounds quirky, but it is far from irrelevant. Only the action of a weak force, changing protons into neutrons, within a star like the Sun allows nuclear fusion to get off the ground within its core at all. There are protons and they're changing into neutrons, and that is when beta plus decay. There are protons, into neutrons, that's beta plus decay. And that allows the nuclear fusion to get off the ground. The weak force is so weak because, unlike the master's photon that carries the electromagnetic force, the three boson particles that carry it, the W plus, W minus, and Z0, are very massive. According to the rules of quantum field theory, they seldom bubble up from the vacuum. They seldom bubble up from the vacuum and have only a very short range, 10 to 80 meters, let me say. The existence of these particles was confirmed in 1983. In fact, as was discovered in the 60s, the weak force and the electromagnetism were part of the same unified electroweak force in the early universe. There was the electroweak force at the beginning of the universe. And then it cools down. The universe of the force. Maybe the universe. And then, like gas condensing to it, like water condensing to dirt, or whatever, the electroweak force broke apart. The process led to the W and Z particles gaining their mass, and now they got their mass. Why did they got their mass? It has something to do, probably, with this flavor changing. And this flavor changing has that something to do with the beta plus decay, the protons are changing into neutrons. But was flavor not just switching from electron neutrino to tau muon neutrino? But we're getting closer. We have basically all just unsorted, but we have all. Well, at least these parts. Now, through this process of condensing of electric force, they could get mass, which makes it possible that they can get off the ground at this. They can get off the ground. Whatever. This process, while the photon stayed massless due to the interaction with another field, the photon is interacting with another field. What is the photon? The photon is not part of standard model. The photon is light, so far do I know it, but I don't really understand it. Why is it not called light? Yes, that's why it's called a photograph. And photosynthesis. Due to the interaction with another field and its associated particle, the Higgs boson, whatever, the photons are hanging out with the Higgs boson. Now, I think if we keep that in mind, we're not that off here. That means if you were here for particle physics, you can go directly to the next part of particle physics. If you stay and participate in the next stretching, then it's better to have this. First exercise. We have a hydrotower. Go to the 7 stance and you're reaching with the fingertips as far as you can. You're breathing in. Then reach as far as you can with the fingertips. Breathe out, reach as far as you can. And out. Reach as far as you can. And out again, down. Next exercise. Now your arms are short. And reach again with the fingertips as far as you can. My arm as far as you can. Not just to the side, but also back. Reach as far as you can. Now time. Reach as far as you can. Next exercise. Have the feet standing together. The arms up to a T. The push up and we're pretending to fly. Our next exercise. Police officer. Breathe in the arms up. And breathe out and the arms to the side. In up. And out on the other side. And in up. And out and down. Next exercise. Go to the same stance. Shoulders back. One up. Breathe in. And out, bring the head out to one side. Breathe again. And out, chin down to the clavicle. Breathe again. Out, lift the gaze and bring the head over to the other side. Breathe again. Out, chin down to the clavicle. Breathe again. Out and lift the gaze and bring it back into the middle. Now bring it all again to one side. Breathe again in. Lift halfway out and then circle the head over to the other side. Breathe again in. Out halfway and then circle up. And back into the bed. Now we'll fly. Bring the palms of the hands together, bring the elbows together, and lift the hands up. As far as you can bring them up, elbows together, forward fold. And again down. And another time, lift the elbows up. And down. And the next exercise. A similar one. Hands together, breathe in, turn up. And out, reach for the front and bring the head down. Breathe out. And in. And out to the front and head down. In the middle. Now the cashew. Feet are standing together. Hands intertwined behind the back. Breathe in. Pull up, shoulders back. I'll bring the head over to one side. And the chin down to the cloud. Breathe again in. And out and pull the hands down to the ground. Breathe in this way. And turn it over to the other side. Breathe in. And out the head down to the chin down to the clavicle and pull the hands down to the ground. And lift the gaze and bring it back into the middle. Now the stretch of fingers in the front way. Fingers behind the back and bring them over to one side. Breathe in, turn up, shoulders back. And out and turn the head over to the side of the hands. Now breathe in. And out, bring the chin down to the clavicle, pull the arm and shoulder down. Lift the gaze, bring it back in the middle, over to the other side, hands over to the other side, breathe again in, taller. And out, chin down to the clavicle, and pull the arm and shoulder down. In lift the gaze, bring it back into the middle. And now with the feet standing shoulders wide apart, one hand behind the back. Breathe in, lift the arm. Breathe out, bring the head over to one side, but don't pull. And breathe in. And out, look up to the hand, which is on the head. And to the other side. Hand behind the back. Breathe in. And bring the head over, don't pull, just bring it over. Breathe again in. Out, look up to the head. And release. And now have the feet standing together, breathe in, lift the arms up. And before it lean back, long arms. Breathe into the middle. And out and lean again back. Breathe into the middle. And out the arms down. And if you get swings, breathe in, lift the arms up. Out the arms down. Again, in the arms up. Out and down. And last time up with the arms. Hands to touch and now the hands down to heart center. That was neck stretching. I thank you very much and until next time.